Hi, today we're looking at section 6-1, Solving Systems by Graphing. Take something out to take notes on. You can pause the video at any time and complete the check it out problems after each of the examples. And as a reminder, you will need graph paper because we are solving by graphing. So we'll be doing a lot of graphing of equations. Our two learning targets today: I can identify solutions for linear equations in two variables, and I can solve systems of linear equations in two variables by graphing. So a system of linear equations, that's just a set of two or more equations with two or more variables. X and y is what we'll be looking at. And a solution is going to be where those two lines intersect. So it's going to be an ordered pair that satisfies both of those equations. So if an ordered pair is a solution, then it will make both of the equations true. So let's see if these are solutions or not. Our first one, we're given the ordered pair -2, 2. And our system of equations is x plus 3y equals 4. And our other equation is -x plus y equals 2. So we're going to substitute in our ordered pair into x will become -2. And substitute in y of 2 into our y and see if each of those equations are true. So our first one, we're going to get -2 plus 3 times 2 equals 4. So -2 plus 6 equals 4. So we get 4 equals 4. And yep, that's true. Now let's check our second equation. Negative, and our x is a -2, so notice there's two negative signs here, plus 2 equals 2. So we end up with, we get 2 plus 2 equals 2, or 4 equals 2, and that's not true. So therefore, this ordered pair is not a solution because it does not satisfy both of the equations. The second equation was false. Now let's move on to B. And again, we substitute in for our x, and we substitute in 2 for our y variable. So let's go ahead and write those equations out with those substitutions in there. So 2/5 times our x minus our y equals 0 is one equation. Let's go ahead and simplify this. So 2/5 times 5 is going to be 2. So 2 minus 2 equals 0. 0 equals 0. That's true. And let's substitute in for our second equation. 3 times x, which is 5, minus 2 equals 13. 15 minus 2 equals 13, or 13 equals 13. And that is true. So yes, in this case, this ordered pair is a solution. It satisfies both of our equations. So here are your check it outs. One thing to notice, in our book, systems are represented using this bracket. Some books won't have those. You might see those on a test. But when you have two or more equations with two variables, that becomes a system. We have an x and y, two equations. It's a system of equations. Another way of finding solutions is to graph them. And where the two lines intersect is going to be our solution. So our first graph, we have y equals 2x minus 1. Remember slope-intercept form. Y equals mx plus b, where m is our slope and b is our y-intercept, or a point, when x is 0. So we have a point 0b to graph. So graphing this one, we start at the point -1 as our y-intercept. We'd go up 2 and over 1, up 2 over 1. To graph our second equation, y equals -x plus 5, our y-intercept here is up at 5. Slope is a -1, down 1 over 1, down 1 over 1. And at this point, at 2, 3, the two lines intersect. That tells us the point 2, 3 is a solution. We can put those values in like we did in the earlier examples, substitute 2 in for x, 3 for y, and both of those equations will be true. So let's solve this system by graphing. Again, these are both in slope-intercept form, so they're in a great form to graph in. If they weren't, write them in slope-intercept form. And then you'd be good to go. So let's go ahead and graph the first one. Y equals x. If you remember, that is a direct variation. has to go through the origin. When x is 0, y is 0. When x is 1, y is 1. So it's going to look like this. We draw our line in, and it's going to look nice, a straight line. When you're graphing, graph these on graph paper because we already have, graphing is already inaccurate to begin with. So drawing our line in. And now graphing our second equation. Y equals negative 2x minus 3. We start at the point 0, negative 3 is our y-intercept. And the slope is negative, so we can go up 2. We have to go over this direction, or down 2 over this direction. Again, we can draw our line in. And use a straight edge to draw your lines, so they are nice and straight. And since they are lines, they go on forever in each direction, so arrowheads on both ends. And looking here, the graph, the two lines intersect at this point. So the solution for this is going to be at the point negative 1, negative 1. We can substitute both values back in. Negative 1 equals negative 1, check. And negative 1 equals negative 2 times negative 1 minus 3 equals 2 minus 3. Negative 1 equals negative 1. Both of the equations work out. For B, solve this one by graphing. So this one, we had to guess or estimate. Again, the graphing is not accurate. And we'll see that in this case here. So we graph both lines. The red line represents our first equation, and the blue line represents our second equation. Notice for the second equation, we wrote it in slope-intercept form. Then we graphed them, and the point of intersection is this orange dot here. So I drew a line going up to where it crosses the y-axis, and from that point over to where it crosses the x and y axes, and had to estimate. I estimated the points to be at 3 3/4 and negative 2 1/2. Again, I just had to estimate. You might say, well, it's actually negative 2 1/4 for the y, possibly. So checking our answers for the first equation, plugging it in, dealing with our fractions, common denominator to add or subtract, we get negative 25/4 equals negative 6. That's very close. It's not exact, but it's close. And same thing for our blue line. We end up with negative 15/12 equals negative 1. Again, that's close, but we're graphing, so your neighbors may have it a little different. This may be, point of intersection may be a little bit different, but it can't be very far off. So now you have two check-it-outs to do. Here's your first one and your second one. Again, this one has fractions. Remember, it's a slope, so rise over run, go up 1 over 3. Now let's move into a story problem. Wren and Jenni are reading the same book. Wren is on page 14 and reads 2 pages every night. Jenni is on page 6 and reads 3 pages every night. For how many nights will they have read the same number of pages, and how many pages will that be? So first we have to write our two equations out. So looking at what Wren is, he's on page 14, he reads 2 pages a night. So he starts on page 14 and he's going up 2 pages every night. And Jenni is on page 6 and she reads 3 pages every night. So graphing those two equations for Wren, we start with the y-intercept being 14. We go up 2 over 1, up 2 over 1, continue on. For Jenni, we start at the y-intercept of 6. We go up 3 over 1. And they intersect up here, and that's going to be when, at 8 nights, it's about 29 pages. So here's your check it out. Graph those two, write the two equations, graph them, and see where the two lines intersect for a solution. So to summarize this, if an ordered pair does not satisfy the first equation, there's no need to check the second one, but it does need to satisfy both in order to be a solution. So here are the steps. Graph the two equations. If need be, rewrite in slope-intercept form to help you graph. Remember, slope-intercept y equals mx plus b. Once you graph them, use a straight edge to draw your lines because graphing is inaccurate to begin with. Find the point of intersection and then plug that point back into your two equations and see if they're close enough or exact. If you have any questions, bring them to class, and thank you. Have a good day.